So because it said increase by, I use the simple growth equation. But now I've got to figure out what numbers go where. So 30,000 goes in the A spot. So I write 0.05 in the R spot. And then here's the thing about T. 1960 is the only thing that deals with time. But when you're given a year and you're using this equation, one of these simple ones, I want the number of years, not a year, if that makes sense. I'm not going to put 1960 here. That's actually not a model. When I have a model, I'm going to keep two variables. And most of the time, I'm going to keep the t as the variable and the y as the variable. So for a model, if I clean this up, we're looking at y equals 30,000 times 1.05 to the t power. I have, sometimes we have this gut instinct like, hey, can I distribute that 30,000? No, don't do it. Don't distribute the 30,000. This 1.05 has to be raised to a power first and then is multiplied. And I don't know that power yet. So this is the model. If you get a question tomorrow on your quiz and it says write a model, I'm looking for an equation with variables in it. So in B, if I'm trying to approximate the value of the land, I'm going to use the model by taking 2010 minus the beginning year that we're starting off with. So 2010 minus 1960, I think we're looking at 50 years that we're going to plug in. This is our total. What is that? $344,021.99. What's nice about this, let's go back to the context. Person inherits land. Land should, well, typically gets more value as more years pass by. So it started out at $30,000 in 1960 and then all of a sudden jumps to $344,000. That's an amazing piece of land. It's great. Hopefully you inherit land someday. We're going to go on to the next one. You purchase a piece of equipment for your landscape business for $150,000. Value of the equipment depreciates at a rate of 8% each year. Write a model for the value of the equipment. So if I see the word depreciates in the instructions or in the word problem, I'm going to use the simple subtraction formula. Okay, now I've got to figure out what plugs in where. I'm just going to clean it up after I put all those in. So 1 minus 0.08 becomes 0.92 raised to the t power. This is my model. I cannot distribute that $150,000. I can't stress that enough. We cannot distribute that. That 0.92 is being raised to a variable. So then we're ready for the second piece of the problem. We're going to use our model to find the value of the equipment after 5 years. So let's see. Ooh, this piece of equipment that you bought was $150,000, and then all of a sudden 5 years later you sell it possibly for $98,000. That stinks. But pieces of equipment, I mean, when you use it, you lose the money. So we deposit in an account $2,500. That earns 2.5% annual interest. We're going to find the balance after 3 years if the interest is compounded quarterly. Now I need to figure out what these amounts go into. So because the problem says quarterly, I'm going to plug in a 4. I also want to stress this about the rate. Sometimes when we see the rate written already in decimal form, we're like, oh, that decimal needs to be 2.5 here. But you will always move that decimal point. If it's written as a percent, you have to move it when you get into that equation. All right, so let's clean it up before we do this all in our calculator. So we get $2,547.17. So we started out with $2,500, and then we end up with, well, a little bit more after 3 years. Okay. That's what we should see. if we don't have a big percent annual interest, we should probably see this. Not a big increase. All right, let's go to monthly. I'm going to clean it up before I put it all in my calculator. Whenever you compound monthly, it should be more than if you only compound quarterly, because this is tacking on interest every month. So it should be more. All right, you deposit $725 in an account that pays 4.5% interest compounded continuously. What is the balance after 3 years? So this is the last formula we haven't dealt with, the Purdy one. So we get this set up. Before you compute this, because I have a lot of people putting in their calculator what they see here. They have E caret, open parenthesis, 0.045, close parenthesis, open parenthesis, 3, close parentheses. Bad thing is your calculator sees that as the following. If you tried putting this into your calculator like what it looks like, your calculator thinks you're doing this. Bad thing is I went 3 in the exponent, so my suggestion is take 0.045 times 3 first, clean that up. We clean it up and then let's compute it. So let's see, we go from 725 to 781. Okay, so 829.79. We went from 725, compounding continuously, gets it up to $800. Sounds about right.